Today we are starting our last section of the year, 12.6, and it is on probability and decision making. So the good news is all of these things you have seen before. We've seen simple probability before. We have seen expected value before, and we've seen probability distributions. And this is a good summary of all three of those. So you can see here, you can read the descriptions of each one of them. You can also look at the applications of when we use them. So for simple probability, we use them to select the most favorable outcome among random events. Expected value is used to compare expected values to choose the best of several options, and compare expected values to decide if a game is fair. That's going to be important today in our example. So our example today, we're going to use simple probability and expected value. And then we've learned before about probability distribution, and that is used to compare expected values of several different options. And if we wanted to create a graph of the probability distributions. So let's talk about this example. We have a game being played. Thedo places 3 cards in a hat and challenges Helena to a game. Thedo says, if you draw a number greater than 2, you earn 2 points. Otherwise, I earn 2 points. Is the game fair or unfair? If it is unfair, which player has the advantage? Explain. So we're going to figure out, because Helena's playing the game, we're going to figure out what is the probability that Helena earns 2 points. So that means she gains 2 points. Well, she gains 2 points if she picks a number greater than 2. The only number that's greater than 2 is 3, so that's 1 out of 3 possibilities. And then let's find the probability that Helena loses 2 points. She doesn't lose 2 points, but Thedo earns them. So in this game, we're going to count Thedo earning 2 points as Helena not being able to earn them. So she lost 2 points. And that would be 2 out of 3, because Thedo earns 2 points if Helena doesn't pick a 3, essentially. So we have 1/3 and 2/3. Let's figure out or use the expected value to figure out if the game is unfair or fair. The expected value will tell you what potential points can be earned by each one of them. So expected value, the probability of Helena earning 2 points, she's going to earn 2 points, and that is a probability of 1/3. She could lose 2 points 2/3 of the time. So remember, with the expected value, we'll multiply the amount of points, amount of money, whatever it is, by the probability. And if we're losing value, we're going to subtract it. So that's why we have -2 times 2/3. Simplifying this, we get -2/3. So this game is unfair, because Helena, there's no chance for her to potentially earn more points than Thedo. Thedo has the advantage in this game. So the game favors Thedo. If it was fair, the expected value would equal 0, because we would have equally likely events. So now Helena decides to propose a change to the scoring of the game. She says, if I draw a number greater than 2, I get 2 points. Otherwise, you get 1 point. Is the game fair or unfair? Now, if it is unfair, which player has the advantage? So our probabilities didn't change. Our probability that Helena has 2 points is still 1/3. But now we have the probability that Helena loses 1 point each time. That's 2/3. Each time Theta picks a card, each time Helena picks a card that's not greater than 2. So now we have the probabilities. Let's figure out the expected value. The expected value, Helena gains 2 points, potentially 1/3 of the time. She has the probability of losing 1 point 2/3 of the time, or Theta gaining 1 point 2/3 of the time. Simplifying this, we get 0. So in this case, it is fair. When the expected value of a game is 0, the game is fair for both players. So now you guys can try the lesson check on your own